Thanks everyone for joining. Happy Monday. And this is a UDF meeting. And continue with last week's meeting. We talking about the remove the version change, global version lineage change to the just logs, which is reflecting the recent PR. We're talking about we add, maybe I should share my screen so that's easier. So we talking about adding types into each field. Right now, I'm adding the Iceberg types. I have the debate with myself and Stephen about whether we need the JSON type because JSON type is kind of weak types. It does not have like integer or long. It's weak, and I think right now I try to be consistent, just adding the Iceberg type. Maybe that's fine. I need a feedback from you guys. It's more kind of a strict type, which is beneficial for the serialization and deserialization. I think we Ryan.
Sorry, I didn't mean to interrupt. I like the idea of making all of these things Iceberg types, which kind of fits with what we, the spirit of the table spec. Because what I was trying to do was anything that was basically an object, specify it as a struct, and then say, the representation in JSON is a struct as an object with those field names and things like that. So I think that sticking to Iceberg types is probably a good idea.
Thanks. Stephen?
Yeah, initially I was thinking about Iceberg type, but later on I think the example below at the bottom of the spec is the JSON. Seems to me like this will also match with the JSON examples on encoding side.
I think it's pretty straightforward to convert from an Iceberg type to a JSON type, right? And even in things like the YAML specification, which like all this is gonna go into the REST YAML spec too, right? Usually there we have even tighter constraints, right? So you'll say like, hey, this is an integer, but it has the full like 64-bit integer range. I forget exactly how you do that, but
okay.
Thing. So I think that it is fine to say like we have specific Iceberg types for these things, and then like it's pretty natural to convert to JSON from there.
Sounds good. Yeah.
Yeah, I think conversion is very easy because JSON, it's quite a weak type. So you can basically, it's only like 4 to 5 different types, and we can very straightforward convert like long int to the numeric and the list to array, things like that. Cool. I think Tarot have some comments whether we need to do the non-handing. I made that change in the latest version. We think we can discuss a little bit. I think Ryan has some comments on that as well recently, a few minutes ago. Thanks for reviewing. Okay, I think that's most from my side. I'm sorry I didn't get a chance to make a POC yet, but I will get it started with like this week or next week. Ryan, I saw a lot of comments from Ryan this morning. I think one of the issue is the overload ID. Maybe we should talk about that.
So I think it's actually the identity of overloads that is,
right.
is the most that I think needs the most discussion, because I think that we have unstated rules, or at least implied rules around overloads, right? Because we basically think of an overload as, a unique object, adding the overload ID, right, kind of muddies a bit of what you can do in the spec. For example, there's the section where we're talking about these things are immutable. Well, immutable with respect to what? Right? Is it immutable with respect to the overload ID? And if you want to make changes to those things, you have to, create a new overload ID. I mean, that sort of uncertainty, I think, is something that we want to clarify. So I would say, in this section on an overload, probably move the parameters, up, and talk about parameters first, and say, what defines an overload, right? And then we want to be clear, if the overload ID is just to very easily encode for this thing, here's how the version changed, I think we're all good with that. But we should make clear, like, what is the definition of identity for an overload?
Yeah, I think that makes sense. I think these two immutables. First, we're talking about the parameters, the order of parameters, and the type of each individual parameters is a signature, which is kind of a essential part of how this overload has been be different from the other overloads. I do see one of the interesting stuff is if we remove one overload and create another exact same parameters, do we consider them as the same overload because their ID will be different?
And that's where I would be very clear that, there is no, because that would put engines in a position where they don't know how to choose between overloads. Right. And I think we all intend for there to be no way to have foo of int and foo of int as separate overloads. Right. So to me, the definition of an overload is the types and order of types in the parameter list. And
yeah, exactly.
Here, I would be very clear that the types and order of types in the parameter list define what must go into the same overload, or the same, set of definitions or versions or whatever. And then I would also recommend being a bit more, taking a different tactic rather than saying what things can or cannot change. Define what consistency looks like. So, for example, in the table spec, we don't say you can only do these operations to table metadata and not these operations. We just define what proper, well-formed table metadata looks like. And then it is up to engines or, integrations to transition between those valid states. So here, where you're saying that we cannot, for example, rename a type parameter, or sorry, a parameter to a function. What I would say instead, what I would recommend saying instead, is that the parameter name must be consistent across all versions of the function, right? Because if you wanted to go and remove all prior versions and basically like drop the overload and then recreate the overload with a different name and a single version, I think it would be totally fine to do that, right? The only thing that we're concerned about is having a parameter name that doesn't match the SQL embedded in that function in one of the versions. So just say the names in your SQL and the names in your parameters must match for all versions.
Yeah, I think that makes sense. Sure, it's kind of for me, it's a clear definition why we cannot change the name because we have to match different version. And this also, I think it's the least dominant for engine to behave.
Yeah, and that way, like it's clear like what the requirement is, and it's not like, hey, you can't do this thing, because then there's the question of, well, can I do what I want, right? If I want to drop foo of A and define foo of X, right? It's clear that the requirement is that all of my versions need to say, require parameter X. And it's not like I can progressively drop older versions and then drop a function overload and then re-add that overload. It's like with the immutable version, I know I can break up what I want to do in discrete changes to actually get to that final change. And we don't want to make people do that or make engines do that, where you're breaking up changes. You can just say like, it's perfectly valid to transition directly from foo of A to foo of X, as long as you rewrite everything.
Yeah, I think that makes sense. We can still like allow user to drop small overloads with grids with the same signature, but that means you could change the name in that case, but within the same. If you don't drop the ads within the same, you cannot change over version for the name. Kara?
I am not clear one thing. That's why I just want to get our overall, the knowledge for that. My understanding, engines, they don't check the name itself, right? They are just checking the type and order of the function. Let's say that I have foo as the parameter, and foo1 is the parameter, but both of them is integer. If I write reverse order on my SQL query, it will not know that.
So I think it helps to go to the example here. Like if we say, here,
Maybe.
right? If we have the body of this function that is x plus 1, right? And you have some parameter x, Trino needs to know what x is in the body of this function, right? It needs to say, okay, I understand that the first parameter to this function was called x, and substitute that value in when it's running this SQL fragment, right?
Yeah.
Because you could have something that is not associative or commutative. You could have like x, raised to the power of y. And in that case, it really matters, which order your parameters are in, or that, x is filled in as x and y is filled in as y.
Yes, but the engine doesn't know the name of the alias of two variables, right? They are just knowing that position of the variables on the signature.
So I think that the engine does need to know the name.
Okay, I will look at the code for that.
Because the engine is going to be substituting these variables in, and basically, so the engine's going to take this fragment, right, this expression, substitute it into an expression in place of the UDF. It then has to go and resolve the names, right? So that expression has input values, and the input values are, those things by name. So yeah, if you call foo of 1, 2, we need to know that 1 gets mapped to all the x's in that SQL fragment, and 2 gets mapped to all the y's in that SQL fragment, or vice versa, right? You have to analyze the plan in order to do this, and that analysis happens by name.
Okay, thank you.
Mm-hmm.
Yeah.
So
Okay.
one follow-up question. So if we define the function, let's say overload the signature by the order and the type, So I think one earlier comment, do we need the overload ID? I guess we don't need it.
So I think if we define identity by the tuple of parameters, right? Or the tuple of parameter types, because you would not want parameters to, like different names for those parameters to allow you to have different copies of a function, right? So if you're doing that, then the overload ID's only purpose that I saw was to correlate the
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 logs,
definition
right? Definition logs.
right now. Then I mean that seems like a perfectly good use to me, but I worry that there is some confusion possibly introduced by that.
Another thing I think it might be used for is because, for example, for this particular overload, we can drop that and we can create new overloads with the exact same parameters. In that case, this ID will identify, okay, this one actually has different versions. Like they have two versions right now, but when we move to the next one with same parameter, they only have the one version, for example, like overload 3 with the same parameter with only one version. We cannot say, okay, overload 3 has 3 different versions because they have the exact same parameter as overload 1.
Well, that's what I'm saying should be illegal.
Yeah.
I don't think that you want to have, and there's a good reason for that. If I have two overloads with the same parameter types, then engines don't know how to choose between them.
Yeah.
Right. I think it should be illegal. My point is we can do a check, say, okay, you cannot do that unless you drops the same signature, right? But like from the timeline, like at one time point, you can have overload ID with the same parameter, but once you drop that overload ID one, you can actually create the next overloads with the same parameters. But their version history are actually different because for one, you potentially have two versions. And this next one, when you create, you can change the name and the version representation version are actually different.
So I think it helps to be very specific about what is happening here. So are you saying that we have the same parameters and names?
We have a same parameter order and type, which is essential part of the.
Just a second. Sorry.
I just asked the Gemini meanwhile for what is illegal for the overloading for SQL standard. And it says that if it is same signature, with the variables, it's illegal.
Right. We should not allow the signature with the same type and order within this like same time frame. The use case I'm talking about is if we drop the overload of 1, then this signature has gone. Then we can create overload 3 with the exact same signatures with order. In that case, we actually change the name. Name doesn't matter in that case. And with the overload version here is 1. Then these two overloads has different version history, even though they are represent the exact same signature.
So yes, technically they do have a different version history. And that's just because our name requires that they have separate histories, right? We can't keep the version history around for when the name has changed. But I'm arguing that the only reason we consider these things different is because we've assigned an overload ID. And that's why overload ID is confusing. Because we're saying that I have some, function foo of int, and then I change foo of int in some way. Like, I don't think that that's a different thing. Right? And it'd be nice to keep around the version history, but we can't with the name. So, I mean, this is why overload ID doesn't make sense to me as an identity concept, because we're splitting identity of two things that have the same identity, right? We're saying that foo of int is a thing, and I have two foo of ints. Well, that shouldn't be possible, I think. So as long as we're clear about the scope of overload ID, right? We could say like, yes, you can assign a new overload ID, or when you rename parameters, you just have to make sure that all the parameters have the single name. But if we have two things where these cannot coexist in the definition, right? They can't coexist in this UDF because they have the same thing, then overload ID makes that, I think, more difficult or more confusing. I'm not against it because I know I understand the purpose, but it would be pretty nice to have a different way of doing this. Now, here's an alternative. I don't know if we want it, but we could have a global version number. So essentially all versions of the UDF are assigned a new number from the same, sort of version, latest version number or something like that, last assigned version number. And so in, foo of int, I get version 1. In foo of long, I get version 2. In foo of int, when I replace it, I get version 3. And so I have unique version IDs everywhere. If we do that, then you would be able to identify the current version in every definition as it changes, without an overload ID, because the version IDs are unique across all definitions, or sorry, all versions. I realize that is also not great, because then it's just kind of confusing because you don't know, like, for this overload what the current one was. You would have to look up all the current ones and then sort of slot them into overloads. I don't really like that, but I'm a little uncomfortable with overload ID as well. We could also define something that is like a key. So we could say like the overloads are, so imagine that we take the set of parameter types, stringify them, and embed those in one big string separated by commas. So we have like foo of int produces paren int comma int end paren, and then we have those strings as our definitions that align one-to-one with the IDs, or sorry, the identity of these overloads.
If I get it right, we can do we kind of an array of types, which keeps order and the
Exactly.
types.
A
Right.
tuple of type names, essentially. As a string.
Right. I think that's probably a good idea. Means every time we refer to this overload, we use this as an ID, right?
Yeah, and that also is, pretty clear. It aligns with our definition of what identity is. If we define this well, then we get a single string key that can identify these things, right? Like that is in itself a kind of nice property. And then it doesn't have the same problem where we're not dividing the identity of something that is not divisible. We actually have our IDs align perfectly with our parameters.
Stephen?
Yeah, I think I agree with that. But we also need to kind of clarify the return type when should not be part of the signature, right?
No.
That is a separate thing that we need to determine.
And let's say if the return type, if they widen, let's say change from return from int to long, whether it's allowed or not allowed, we need to kind of clarify all those.
Yeah, I think that the semantic that we discussed before for return type is that a function definition has one and only one return type, and you need to ensure that what you produce is either castable to that return type, safely castable to that return type, or is that return type. And that's just for, some weird cases. I think I have an index of case where you're returning index of, essentially. And you might have different index types across SQL definitions, but you would be able to say, both index of either produce an int or a big int, and we can upgrade or, widen the int to a big int. So it would be fine for a definition to use big int. It would also be fine for a definition to use int, but then any system that produces big int would, be required to say, I produce values that are too wide for this, and therefore it can't be used.
Yeah, I think previous discussion about the return type is not a part of the signature because, like, if we look at the all these engines, even programming language, we don't usually overload by return type. It's mainly about the parameters. It causes some issues. There's some minor, like there's some maybe niche engines support return type overloads, but the kind of we cannot find enough of them. Most of them using does not using return types for the overloads. I'm still trying to understand if we do this way, then every time we remove one overload, the version history will still be a little bit confused because right now we have the exact same overload ID if we do this way.
So I would argue that there are different interpretations of this, but if I replace foo of int with a new version, maybe what you're doing is, alter function, I forget the SQL syntax, but you're basically running alter function foo of int, here's a new body. And so you could look at that if you have a different name for one of the parameters as an entirely new definition of that function. But I would argue that it's just as valid to say that that is the same definition with a, it's the same function with a different definition. It's a new version of that overload. And so I think in order to do this, it's perfectly reasonable for you to say, yes, I may think of this as a different foo of X instead of foo of A, but you're going to get, version 3. And I don't really have a problem with that. I think it's an equally valid interpretation of replacing the function definition.
Yeah, maybe we just abandon the name change, then that we can still keep the version history 1, 2, 3 in that case, because as long as the name is not changed, we don't usually have a problem for that. We can just carry on this version to the new definition. Even you drop the whole stuff, but we still somehow keep that version in somewhere.
Well, so this is up to, I guess we have a couple choices on this. I think that this is up to engines. If we say that the name has to be consistent across all versions, engines could just go back and rewrite those names, right? They can parse the SQL, do a name replacement, and put it back in. I don't know that anyone is going to do that. And I don't really have a problem losing history if someone does. The trade-off there is, we could have a system in which you don't actually rename, or sorry, you don't you don't have a requirement that all the names are consistent. So maybe you could have, a failure, right? So if I have foo of X and I replace that with foo of A with the same parameter type, then you could imagine that a rollback puts the UDF in a state where it can't be used, right? If I have some form of rollback. That's not great. And I would probably say it's worth the rule to make all the names match, right? Like it's better to have the ability to roll back to a working version of the function than to be able to rename parameters easily. But renames would really be an engine decision at that point, because the engine is responsible for rewriting all the older versions. Another option is to add aliases. And so you could say like, hey, X has also been called A. And so we would have like a list of names. And you would basically be able to say, if you see an A, it is position 0. If you see an X, it is position 0. I think that that's overcomplicating the spec. But like we could do all these things.
Yeah, is it okay to say, okay, we don't allow rename? Because I didn't see a lot of use cases like really want to rename that particular parameters. Is that really necessary to rename? Or so, we can lose a little bit. Let's say, okay, if you really want to rename, we don't recommend rename. If we really want to rename, there's no way to fall back.
I think it comes down to, we want to provide rules not for how you can change this thing, but for what is a consistent and well-defined UDF. And so we can have a rule that says the name must match in all versions. And that is a reasonable, consistent rule. And engines can choose whether to rename or to drop history.
That makes sense to me. I think we could do that. If you drop the version, you are fine to rename. Otherwise, you just keep that name.
Yeah, and it's up to engines how they want to deal with that restriction, right? If you want to rename it, cool. Stephen?
Yeah, I think Ron mentioned about rewrite kind of we rewrite all the versions. I think that's probably not feasible considering we have dialect, right? Let's say you have Spark, now you need, because let's say we have Spark and SQL, now you also need to rewrite the SQL dialect.
So it would be safe in cases where there's only Spark dialects, right? So again, I would say if you have the ability to, ensure that all dialects are safe, great. That's totally fine. Another thing is maybe later, and this kind of gets to Talet's, idea. Maybe later we introduce a representation that is a lot more structured. And we actually reference in that representation these fields by position rather than name, right? And in that case, right, x plus 2 turns into slot 0 plus 2. And then we could, rename it will. So in certain representations, you have to rewrite. In certain representations, like we've already done that analysis and you're getting a intermediate representation rather than a unparsed representation. So like leaving this open, I think is probably good. There are cases where you could detect it's safe to rename or not.
Yeah, I definitely agree that we should just define what's the valid representation. For example, the restriction, all the names should be consistent across version. I think we clarify that in the spec. That's all we need to do. I totally agree with that.
I'm good with that.
Yeah, the concern of these orders, maybe like for example, one which is more structured way is the SQL representation. Sounds really weird, like something like this. Could it be?
This is better representation. At least when the Rhine is drop off, I check the Gemini. I don't know is it correct or not. It's AI, but at least it says that the SQL standard is looking to order rather than name, and the name can be changed. But as long as the order is the right and the type and order.
Yeah, in that case, we can just remove this one and it keeps the order. This potential one solution for okay, we don't have any controversy for the name.
I think the problem is then you have a representation that cannot be parsed. So I'm not familiar with any SQL dialect that allows you to refer, and it could be my own ignorance. Like, let me just throw that out there. But I've never seen anything where you refer to function parameters by position.
This is the engine side, right? It's not user-facing functionality.
True, and this could definitely be defined in the dialect of some engine, right? So we could see an engine come and say like, yep, my parameters are going to be defined by order. I think that would be fine. And within that engine's representation, it could definitely say like, you know what, it's safe to rename without even worrying about these things. But that is dialect specific. And I don't think that allows us to elide or remove the name from the parameter list. Because the parameter list, like we need to know the first parameter is named X because we were going to refer to it as X in the SQL.
At least compile time, right? The initial compile time, we need to map the position and name.
Exactly. Yeah.
Cool. Let's move on to potential next topic. Ryan, do you have any more specific comments we want to discuss?
Yeah, we're kind of talking about overload identity and function resolution. It would be good to have, I think, more color on those things. The nullability.
I see.
So there are a couple different nullability things. So first of all, the nullability of parameters. Do we want to make some parameters capable of taking nulls versus not capable of accepting nulls? Then there is, I think, the null handling stuff as well. But I would say, how do we even express, because this actually happens in Spark quite a bit, where you define a UDF and that UDF, Spark needs to know whether it produces null. And that affects, its inference downstream of that UDF for whether there are null values. So
this is not null handling, right?
This is not null handling, because null handling, I believe, is trying to express invariance about the operation of the function. I'm saying, like, say I have a function that is prime or something like that. And if a number is prime, it returns the number. And if it's not prime, it returns null. Null handling doesn't really tell us anything about that function.
Can you go back, Yuffie?
Right. Like, null handling might tell us if the input is null, I must have a null. It might tell us that, hey, I can get nulls out, but like I want to make sure that we know which parameters can be null going into the function, and then whether or not the function can produce a null output value.
I see. You are saying that like nullable on Java, right? Basically, for each the variable, we can say that this is nullable or not nullable.
Right, and we do that in Iceberg structs, or not structs, but structs, but basically all types. So can struct fields be null, etc. Now that tells us something about null handling as well. So if all of my inputs are required, right? So if there's anything like, here's a concrete example. I might have a Spark function that throws an exception if a certain value is null. And I want to use that in my UDF. Well, if I'm using something that could stop execution of an entire job, I probably want to say, like, this is required. If you can't guarantee there's always going to be a non-null value, don't call this function, right? Or something like that. And I'm not saying that we definitely need to do that. What I'm saying is we should consider whether all parameters are inherently optional or whether we can make them required. And we should consider annotating the output type. Definitely consider annotating the output type. Does this produce null values, or is it always non-null? Like a count function is always non-null, right? So even for a null input, you still update your count, for example. So like if it's always non-null and you can guarantee that, then that's a good thing to tell the optimizer, because like Spark will generate different different code to run that, and will skip null checks.
Then we need to introduce the overload side. We need to introduce another field like all of the parameters based on name or position, their, the nullability.
Right. So if we are saying that incoming parameters can be required, we also need to determine, does that required or optional status allow us to, does that change identity? I would say it probably does not change identity.
If I define a user-defined function, all of the parameters are required. There is there is no other way, right? Because I write those parameters, even though you are not passing them, either you need to pass a null or empty string, whatever. Otherwise, you cannot call the function.
Yes. So the parameters themselves are required in that sense. I'm talking about required in the sense of, is it nullable or not? So
That's why I'm saying that.
Can you pass a null value for that?
Mhm.
Right. And that would be, one of the examples above is, x plus y. And if either x or y is null, the function produces null.
Mhm.
Should we have the ability to say this, x plus y function does not accept either null x or null y?
We need to check the SQL standard for that, right? Because the behavior is coming from the SQL standard.
I agree. That is probably the right answer.
Let me ask Gemini. I don't know, is it true, correct or not?
But I just think like that seems to be something that we have omitted from the spec up until now. And I'm curious like how systems handle the nullability of parameters. And also like if you do get a here's what I suspect. All parameters are optional, meaning that they can accept nulls because the analysis of could this expression produce a null is almost always, yeah, it probably can produce a null. Like you would not want to only be able to call a function if you can guarantee that all inputs are non-null. That would be a pain. And if you were doing that, you would have to say like, well, what if I do have a null value? Do I want to substitute or coalesce something? Like, but it would be really good to know like what other people do here and what the expectations are in the SQL standard.
Yeah,
So-
I can go ahead.
So current null handling is a function level config. I guess maybe the advanced question is, should we have like a per parameter? Do we need kind of per parameter level config, whether it's nullable or not? Right, instead of the function level that apply to all the parameters.
I think it's parameter as well as return types, right? We talking about different parameters, x plus y. If y is known, then the function will just return none.
No, the null handling config right now is in the overload version.
That is an invariant. You're talking about the null handling.
Correct. That's in the overload.
Those are invariants, right? You can say, does this produce a null for any parameters null input? Or you can say, you have to call this function if there are null values, but it's not really the same thing either on, like, is this going to blow up if and throw an exception if there is a null value? Or, can this function produce null output values or not? This is more like, when do you need to call this function?
So I have one question. So if we say certain parameters are not nullable, that means ending will make the decision whether it call this function or not. But does that already decide when when they already put function within these, it's secure. Like how do we avoid that when this engine see this parameter is known?
I mean, that's a good point. I think in that case, you would require all parameters to be optional and wouldn't have a parameter, you know, is null, not null kind of flag. But again, I don't know. I think this is an area where we need to do more looking into what is the behavior of engines and what do we need to specify here. It just seems like we need to go into it and specifically call out. You can either mark things as required, in which case we have to specify what behavior should be if you have null values, or you can't guarantee that there won't be null values. And then if all parameters are optional, then we just need to state all parameters are optional. I think we also want to have the output, like, is the output optional or required? You know, will this always produce a non-null value or not?
That makes sense. Yeah.
I did small research for that. The standard is just saying called on null input, or the returns null on null input. This is the standard, and the PostgreSQL, Snowflake, MySQL, Oracle implement in that way. Only Microsoft SQL is implement variable level nullability. But of course, I don't want to cheat you guys. This is Gemini. I just manually check Snowflake, Postgre, and the Microsoft on their documentation. Yes, whatever Gemini say that it is correct. But so I didn't check all of them.
It sounds like most consider all input parameters to be optional.
No, the input parameters is basically required.
Input parameters may be null.
Yes, it can be null, but they are not looking the input parameters. They are looking to return is null or not null.
Right, but null handling is a separate thing.
It is not. That's why I'm saying that. The first SQL standard, they don't care about our function parameters. They care about the overall function is return null or not, except Microsoft SQL.
Okay. Yeah. I see what you're saying. I think I think we still need to look into whether we want to, express this cannot be null. I suspect that we don't, but we probably need to track that down. And then, and then see what that means for null handling. And I also would probably say that we want a flag for the return type, whether or not that can be null.
Cool. Yeah, I do some research on that, especially input one, as well as the return type. I think that makes sense to me, especially for return type. Cool. We have the out of time.
I think we're out of time. I need to run. Thank you, guys.
Sure. Thank you, everyone. We'll see you next week. Bye.